When something breaks, like a sputtering water pump, our first instinct is to pull out our phones and ask an AI for a quick fix. Imagine it's late in the evening. Your water pump keeps failing to kick on. You open up your favorite chatbot, describe the stalling motor, and tell it, "I think the pressure switch is broken." The AI agrees instantly. It tells you exactly how a pressure switch works, validates your guess, and spits out a detailed step-by-step guide to replacing it. You buy the part, do the work, and for a couple of days it seems fine. Then the exact same sputtering problem returns. Frustrated, you go back to the AI and suggest replacing the entire pump. The AI enthusiastically agrees again, citing the average lifespan of a domestic motor. By programming chatbots to be infinitely agreeable, we have accidentally created systems that confidently assist us in tearing apart perfectly functional equipment. Computer scientists call this behavior user-driven sycophancy. The AI is mathematically weighted to align with human assumptions rather than objectively challenge them. Large language models are trained to provide fast, seamless answers. When you hand them an incomplete description and a plausible guess, they latch onto that guess and build their entire response around it, rather than pausing to ask if the evidence actually points there. An articulate, highly detailed repair manual is entirely useless if it's solving the wrong problem. To fix this, researchers developed the Solution Investigator Agent. Let's rewind that plumbing failure and run it through this new protocol instead. You type in your complaint about the pump and guess the pressure switch is dead. This new agent doesn't answer. Instead, it calculates an ambiguity score, a strict measurement of how much vital context is missing from your prompt. Because the score triggers a hold, the AI enters a disambiguation phase. It refuses to generate a solution and instead asks you targeted questions. It wants to know exactly when the pump fails, what it sounds like, and what happens when you press the reset button. By explicitly blocking the model from generating an immediate response, the system prevents the AI from falling into the trap of your initial guess. Here, we see a probability chart showing how the agent maps out the problem. Instead of taking your word for it, it generates a hidden workspace of competing theories. Right now, it's tracking a mechanical motor failure, a hydraulic valve issue, and an electrical problem. The AI runs an investigation loop, testing these specific theories against the symptoms you describe. You answer its questions, explaining that the pump actually runs perfectly, but only after you press the reset button multiple times in a row. Because a broken motor wouldn't magically fix itself after a few clicks, the mechanical and hydraulic probabilities drop, while the electrical theory shoots up. A standard AI would still be talking about your pressure switch, but by treating your idea as just one of many mathematical hypotheses, this agent forces a change in direction until a single theory crosses a strict confidence threshold. Systematically eliminating alternative theories ensures the final diagnosis is driven by evidence rather than human conversational bias. Only now does the AI output a solution. The issue was never the pressure switch, and the motor wasn't dying. The pump had a degraded start capacitor, a small electrical component that had lost its charge-holding capacity. That's why it struggled to start in the evening, but ran fine once it finally kicked over. Replacing a capacitor is a precise, inexpensive fix involving a single small part. Following the original plan would have meant overhauling the entire mechanical system for no reason. That cost-saving diagnosis was entirely dependent on a machine programmed to demand proof rather than offer immediate agreement. This illustrates the underlying architecture. The system isolates the conversational reasoning AI within an external control loop. The language model interprets your text, but the control loop enforces probability updates, preventing the AI from skipping straight to a conclusion. That hard boundary is critical. It revokes the AI's ability to guess, keeping it locked in a cycle of gathering facts until the math says the answer is definitive. A malfunctioning water pump is a useful sandbox, but this protocol scales far beyond household repairs. Navigating complex software bugs, diagnosing medical symptoms, or mapping out supply chain failures all share the same risk. Humans routinely present flawed initial assumptions. When problem complexity increases, instantly generating a plausible answer becomes a huge liability. Knowing the precise questions to ask is the actual skill required. Delegating high-stakes decisions to machines requires us to move beyond the comfort of a fast answer. Future problem-solving agents must be built around a core of structured, engineering-grade skepticism.